Hello, students, and welcome to our November 16th lesson. We're going to start a new unit today, Relations and Functions. So our do now today asks us to respond thoughtfully to a question about our personal interests. Our essential question will be what distinguishes a relation from a graph, and what is the domain and range of a graph. Our assignment will be to watch the video and complete the assigned pages. There are a lot of pages, but I don't think you'll find this work particularly difficult. Our exit ticket asks us to complete the sentence if a blank, well, actually two blanks, intersects a graph more than once, then the graph is not a blank. Our homework will be Unit 3, Homework 1, Relations and Functions. Please note that is 2 pages long. I hope you are keeping up with your chart that I gave you on all of the work that will be due for Unit 3. Of important note, please make sure your Relations and Functions dictionary is complete. So let's get that done. And to keep it positive, we have this beautiful picture that's a reminder of the bounty of fall and reminding us that you are better at algebra than you were yesterday, and tomorrow you will be even better than you are today. And that's something to be thankful for. And I hope you spend a few minutes today being thankful for anything in your life. Our do now asks, is there anything that you used to enjoy but now find to be tedious or boring? You know, that's a sign of growth. You might have something you really used to like doing a lot, but now it just doesn't hold a interest to you anymore. And that's a sign that you're maturing and growing and developing new interests. We'll get back to our exit ticket later. But meanwhile, let's get started on our lesson. Excuse me. Okay, so the topic is relations and functions. I like to write in cursive a little bit so that you do get some exposure to that. So we'll start with something very simple, the coordinate plane. The coordinate plane is a plane divided into 4 regions used for graphing. So we are asked to label the origin, the quadrants, the x-axis, and the y-axis. So the origin is right here in the middle. Put an arrow to that. That's the origin, which is point 0, 0. The x-axis I've just made in green. That's our x-axis. I think I need to change some colors here to make this clear. Here's our y-axis, which is vertical. And we're asked to label the quadrants. Now be careful, we're going in counterclockwise direction. Quadrant 1, 2, 3, and 4, and yes, we use Roman numerals for those. An ordered pair is simply a point on a graph. So now we're asked to identify the ordered pair and the quadrant of each point on this graph. So we'll start with A, and I've heard it said that you need to run before you jump. I'm just going to write down run first, jump, which could be a jump up or down, next. So we're always looking at the x-axis as the first number in the ordered pair and the y-axis for the second number. So the first number, point A, would be -3, 1, 2, 3, positive 4, 1, 2, 3, 4. And there's A. So we write that negative 3, comma, 4, and that lies in quadrant 2. Our next letter, B, here it is, positive 2, negative 3. And these ordered pairs have invisible positive signs, just like numbers usually do, and that lies in quadrant 4. C is on the y-axis, so its x value is 0, the y value is 2, and that is on the y-axis. So that does not lie inside a quadrant. Point D is in quadrant 1, and it is labeled, can be labeled with point 7, positive 1, positive 7, positive 1. Point E is going to be negative in the x and y value because it lies in quadrant 3, where everything is negative. So that would be negative 4, negative 6. And finally, F, which is on the x-axis, is labeled point negative 5, 0. So there's a quick overview of the coordinate plane. A discrete graph is a graph of distinct points. And I'll draw a quick picture of that. So if you had your y-axis and your x-axis, and you had a series of points, let's change our color so we can make that really clear. Okay, that would be a discrete graph. A continuous graph is a graph with connected lines and curves. And again, we'll draw the y-axis and the x-axis. And the curve might look something like this, with each end going on to infinity. Excuse me. Okay, now let's have a brief discussion of relations. Okay, what is a relation? So the definition of a relation is a set of ordered pairs. The set of x values is called the domain, and the set of y values is called the range. So we've got these points here, these ordered pairs, and we can represent them as an ordered pair, or as a table, as a mapping diagram, or as a graph. Let me show you how that works. So remember, the domain is all of the x values. So I'm going to go ahead and put those in order, and I'm going to enclose them with brackets in a kind of set notation, -3, -2, 1, 3. If something's in there 2 times, we only need to list it once. And then the range will be the set of y values, which would be, let's get our brackets, -4, 0, 1, 2, and 5. So we have more items in the range in this particular set than we do in the domain, because we have the domain, we have the value of -3 twice. So when we put those on the table, I'm going to go right in order that they're presented here. The first one is -3, 1. The second one is -2, 0. 1, 2. 3, -4, -3, 5. Now I'm going to take all of these x values and insert them into a mapping diagram, but I do not need to repeat the -3. So I'll put that here, -3, -2, 1, and 3. Now I'm going to take the set of y values and I'll put them in order from least to greatest, -4, 0, 1, 2, 5. And then I'm going to map them using arrows. So -3, go back over here, -3 maps to 1. -2 maps to 0. 1 maps to 2. 3 maps to -4. And -3 maps again to 5. Now let's put those on the graph. So -3, 1. -2, 0. 1, 2. 3, -4. And -3, +5. So now we've represented this set of ordered pairs as a set of ordered pairs. We've listed the domain and range. We've notated them in a table, mapping diagram, and in a graph. So why don't you go ahead and try number 2 and 3. Okay, so let's get started. The domain of this particular set would be all the x values, starting from least to greatest, -2, -1, 0, 2, and 5, enclosed with brackets. The range is the set of y values, working in order. We'll start with -4, -3, -2, -1, and +4. Now let's put them in a table of values, which would be -2, -3, -1, 4, 0, -2, 2, -4, 5, -1. So we have 5 distinct separate x values and 5 distinct separate y values. I'll list them in order in my mapping diagram, starting with my domain, which is -2, -1, 0, 2, 5. Then I'll put the range, again, starting least to greatest, so it would be -4, -3, -2, -1, and +4. And now I will map them together. So -2 maps to -3, -1 maps to 4, 0 maps to -2, 2 maps to -4. Oops, let me fix that. I put it to +4. Okay, so 2 maps to -4 and 5 maps to -1. Now let's go ahead and graph these. So -2, -3, -1, +4, 0, -2, 2, -4, and 5, -1. 1, 2, 3, 4. 1, 2, 3, 4, 5, -1. Okay, last set. So here we start with the graph. So what do we have? Let's take a look at those values. I see -5, -4. I'll darken them when I write them. So parentheses, -5, comma, -4. And another comma. Get ready for the next set. And I see -2, 3. I'll just go from left to right. So -2, comma, 3, close the parenthesis, another comma, open parentheses again. Here I see 0, 3, -3, excuse me. The fourth set is 2, -5. And the last set is 4, +2. Those are both positive. Okay, so the domain, excuse me, so the domain on this group of values, it starts at -5, -2, 0, 2, and 4, and the range, -5, -4, -3, 2, and 3. And again, these 3 graphs are discrete graphs. Let's list our ordered pairs in a table: -5, -4, -2, 3, 0, -3, 2, -5, and 4, 2. And I've gone in order from least to greatest, looking at the domain in this case. So when I put the domain over here, will be in the table of values under X, and it will be the left-hand oval in the table of values: -5, -2, 0, 2, and 4. Now, I'm going to go ahead and list the range, but when I do that, I'm going to do it in order from least to greatest. So it would be -5, -4, -3, 2, and 3. I've got them all. Now I need to map them. So -5 maps to -4. 2 maps, -2, excuse me, maps to 3. 0 maps to -3. 2 maps to -5. And 4 maps to 2. Now, let's talk a little bit more about domain and range. When we are thinking about the domain and range of a graph, I want you to scan your pencil from left to right and identify the X values in which you are touching the graph. For range, I want you to scan your pencil from top to bottom and then identify the Y values in which you are touching the graph. So if we look at this graph, we see that the domain encompasses everything from left to right, everything. It's going to go from negative, oops, that was supposed to be an infinity. Let me try to do that again. -infinity to +infinity. So from -infinity to infinity. So we call that all real numbers. And we use that symbol. But the range, if we take our pencil and look at the range, it starts here at -2, it includes -2, and goes all the way to infinity on the y-axis. Remember, this is the y-axis here. So what we'll say, and we usually use inequalities or interval notation to do this, we will say y, because we're talking about the y-axis, is greater than or equal to -2, because this point here is -2 on the graph. This is actually 0, -2. So that's the domain and range for this number. On number 2, the domain goes from -3 to +3. So we would say -3 is less than or equal to x, and x is less than or equal to 3. Now the range goes from -3 on the y-axis to +3. So for the domain, let's change our color so we can make that a little bit clearer. For the range, we're talking about the y-axis. So our range is from -3 here up to +3 here. So again, it would be -3 is less than or equal to, but this time y, and y is less than or equal to 3. So let's take a look at this next graph. So think about this. We have an arrow on the end of the line. So we assume we're going to go all the way to -infinity and all the way to +infinity. So our domain here will be all real numbers. But our range, let's change our color and look at that. Our range will go from -infinity on the y-axis up to including infinity on the y-axis. So our range is also going to be all real numbers. It's my R, fancy R. Let's look at number 4. We have arrows on the end of this graph, which means we will go to a -infinity to +infinity on the domain. So the domain will be all real numbers. But the range, let's take a look at this. What is this point on the line here? So that is 1, 2, 3, 4, 5. Okay, that's this point where this quadratic turns is at y equals 5. So everything below 5 is part of the range of the graph. So we would say y is less than or equal to 5. And let's take a look at another one. We have this beautiful square, which goes from -1 to positive, looks like 1, 2, 3, 4, 5. So that would be -1 is less than or equal to x, which is less than or equal to 5, because those endpoints are both included. But our range, let's see, let's change our color. Here's the range. So it's the y values, and the range starts at -3, which is less than or equal to y. Y is less than or equal to 1, 2, 3. Okay, I just want to make a point right now to everybody out there. If I'm asking for the domain, you must give me x. If I ask for the range, you must give me y. I will mark them incorrect on a test because the domain is all the x values, the range is all of the y values. Now, looking at this last graph, number 6, we see that this graph will go eventually to infinity, both in the domain, the x values, and in the range. So both the domain and the range would be all real numbers. So why don't you try 7, 8, 9, and 10? Let's see, why don't you finish up the page and then come back to the video? Okay, so let's see how you did. So for number 7, the domain is easily all real numbers. The range, however, is limited. So the range will be from -3, which is less than or equal to y, which is less than or equal to +2. So the range is limited to this section of the graph here. Okay, number 8. So the domain, this is a -1 here. So the domain is x is greater than or equal to -1. But the range, this graph will go on to infinity. It will keep going, going, going. So the range in this case is all real numbers. Okay, number 9. Look what we have here. We have a vertical line. Make it dark blue so you can see it a little better. So the domain is only at one place. And what is this? Well, if we numbered these points, that's 1 and that's 2. So the domain is x equals 2. That's it. However, this graph will go on to -infinity and to infinity on the y values. So the range is all real numbers. And likewise, number 10, we have a horizontal graph. So in this case, the domain is all real numbers. But the range is y equals 1, 2, 3, that's -4. Number 11. So now here's where our open and closed circles that we've become familiar with come into play. So here we have an included point at -2, 1. So on the domain side, -2, we have a solid dot. So we have less than or equal to x, which is less than or equal to, we have an open dot on 1, 2, 3, 4, 5. So that would be 5. And I should not put, there you go, is less than 5. Open dot, we have the less than symbol. Now, as to the range, what is the lowest part on this graph? The lowest part on this graph is the -2. So -2 is less than, because it's an open dot, y, and y is less than, now let's be careful, the highest point of this graph is right here. That's 1, and that is a solid line, so it's included, so less than or equal to 1. Again, scan your pencil from left to right and then from top to bottom. So if I look at number 12 and I scan from left to right, I start here at -4 and I go all the way to here, which is a +5. So -4, and those are both solid dots, so they are included, is less than or equal to x. X is less than or equal to 5. Now the range, solid dot on -3, and I go up to this point right here, which is 1, 2, 3, 4, 5, which is 5, and it's a solid dot. So I'll include the equal sign. So I will have -3 is less than or equal to y. Remember, this is the range, which is less than or equal to 5. And the last two in this section, I have a graph that goes to negative infinity, both in terms of the domain and the range. So in terms of the domain, I have an open dot at 2 on the x-axis. So that would mean that x is everything less than 2, so just x is less than 2. Y is everything, so everything this way is part of the domain, but everything this way is part of the range. So y is less than, and this is 0, 0, because that point does lie on the x-axis. Now our final graph on this page, we have a solid dot at -2, and this graph goes all the way to infinity on the x-axis. And on the y-axis, it starts at -1, 2, 3, -4, and the graph goes upward to positive infinity. So in this case, and we have a solid dot, so we're going to include the equal sign. In this case, x is greater than or equal to -2, so all the way to infinity, and y would be greater than or equal to -4 all the way to infinity. Now, let's start talking about functions. A function is a special relationship between values where each input or each x value has exactly one output or y value. So let's say it's a special relationship between values where each input, I'm going to erase that x, I want to write the word input, where each input, which is the x value, has exactly one output, which is the y values. Okay, so an example of a function would be, let me just try to write that a little neater, and I'll change our color. An example of a function would be the points, let's say 0, 6, 5, -2, 7, 9. Look how I'm putting commas between the numbers and between the ordered pairs, 11, -1. Okay, not a function. So see, here we have each x value has its own y value. Okay, not a function. Here's an example for you. If I had -4, 1, -1, 7, -1, -2, and 5, 6. And herein lies the problem. For an x value of -1, I can either have an output of 7 or -2. So that is not a function. So let's look at these 4 sets of ordered pairs and define whether they are functions or not. So here I've got 5, 3, 2. We're looking at the x values, the domain 0, -1. They are all different. Yes, this is a function. Now let's take a look at -2, 0, 2, 3, 2. Well, I've got this and this, both these sets of ordered pairs have 2 as an x value. So no, not a function. Next, I have -4, -3, -2, 1, -3, and this is a problem. I have the same x value twice. No, not a function. And here, let's look at my x values. 1, 2, 3, 4, 5, nothing repeated. Yes, it is a function. Now, can we ask the same question with the table of values or these functions? Let's look at the 3, -1, 0, 2, 3. I've got a repeat, not a function. Here, again, I'm looking at the x values, -4, -2, 1, 2, 5. We're good. We can have repeated y values, but not x values, so this is a function. Again, looking at the x values, -5, -3, 0, 1, 2. That's okay. Yes, it is a function. So let's look at number 8. We'll look at the x values. I have 1, 4, -7, 4, -1. I have a repeat. So that means no, not a function. Number 9. My x values are -8, -4, 0, 4, 8. All good. Doesn't matter if I have the same y value. Yes, that is a function. And number 10, my x values are 1, 2, 3, 4, 5. So that qualifies as a function. Same question, but this time we're looking at the mapping diagrams. Is each x value mapped to only one y value? Well, looks good because it's okay that a y value is mapped to two x values as long as each x value has an individual y value. So that is a function. But in number 12, we have a problem that -1 is mapped to two y values, So that is not a function. And let's look at number 13. Each x value has its own, is not repeated, so it has its own y value. Yes, that is a function. And finally, one easy way to tell that something is a function is that if a vertical line intersects a graph more than once, then it is not a function. So with a function, a vertical line will never intersect a graph more than one time. So when we are given the graph of a relation, so now we're answering the question, what is the difference between a relation and a function? We answered that question when we looked at these problems, okay? We only have one domain with a distinct range. And that's how we get the vertical line test in the graph, which you'll see in a minute. So when given a graph of relation, the vertical line test can be used to determine whether the relation is a function. The vertical line states that if a vertical line intersects a graph more than once, it is not a function. So then the graph is not a function. And I want to talk about specifically, when I say graph, I'm going to roll this down a little bit. When I say graph, this is what I'm talking about, what I'm highlighting in red here. Okay? I know a lot of students get confused, and when I say graph, they think I'm talking about the coordinate plane. They think that's the graph. That's not the graph. The graph is the line made by the equation, and we'll learn more about those equations soon. So Here, I'm going to draw an x-axis and a y-axis so we can illustrate something that is a function and that is not a function. So my first graph will look like this. Okay, and my second graph will look like this. Sorry, it's not neater. So let's get a new color and let's draw a line, a vertical line through this. If we draw a vertical line through this function, it only passes the function, crosses the function once at that point right there. So that is a function. Now, if I take a vertical line and I pass it through any point here in this graph that looks sort of like a circle, it will pass at 2 points, here and here. So that is not a function. And that's how the vertical line test works. So let's look at some more examples with the vertical line test. Now, let's look at this function. If I were to connect these lines, it would look something like this. Oops. So theoretically, I would be okay with the vertical line test at almost any point on this function except right here. And right here, I have a vertical line that basically overlaps the first step of this graph, which goes from -1, 2, 3, -4 to +1 on the y value, but both of them have an x value of -3. So let's label these points. -3, and that is 1, 2, 3, 4, -4. And this point is -3, 1. Okay, we cannot have the same x value. And that would mean that our graph was a vertical line, so not a function. So if we look at this next graph, we have a point here, 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 and here. If we were to connect those lines, no matter where we drew our vertical line, it would only pass the graph at one point. Remember, it's a vertical line. So yes, this is a function. Let's look at number 16. Again, we'll try putting that vertical line test everywhere. It only passes through the function at one point. So this is a function. Now, look what happens with number 17. If I take a vertical line and put it through that quadratic, it's going through 2 points, not a function. Number 18, I'll try the vertical line test at several places, and it goes through 2 points, so not a function. Now, I always get students that say, "Oh, Mrs. Gold," this is what they say, "you could put it right there and it would pass the vertical line test." Technically, yes, but let's look at the vertical line test definition. If a vertical line intersects a graph more than once, we're talking about at any point. Okay, then the graph is not a function. So back to number 18, it would have to intersect at only one point at all of these points, and it is not, so it's not a function. So let's look at that was 18. Let's look at number 19. Again, the vertical line test passes. It only intersects the graph at one point at any place on the graph. So that is a function. But look at this. If I put a vertical line on this graph, it would intersect at every single point on the graph. The vertical line is the very definition of not being a function in terms of our visual graph. So this is no, not a function. But number 21, we can pass that vertical line through any point on the graph, and we will only cross the graph at one point. So that is a function. So you've worked pretty hard today Let's go way back to our exit ticket. Okay, this is the vertical line test. So that was our first clue, the vertical line test. If a vertical line intersects a graph more than once at any one place, folks, not just the tip of a circle, then the graph is not a function. So, welcome to Unit 3. Welcome to our study of relations and functions. Don't get behind on your work. Many of you found out that that is not a really good feeling. We want to stay ahead of it, and then you understand better. When you understand better, you get through it quicker and you have more free time anyway. So please, please, please stay current with your work. And if you practice, I know you'll be great.